Yeah, hello. Yeah, very good evening to all the faculties present here. I hope I am audible. I hope I am audible. Hope my screen is also visible to all the faculties. Okay. So, a very good evening to all the faculties present here. So, today we have a day number 3 for cohort 1, where we are going to be uh, discuss about artificial neural network, where we will also take one use case or a case study in which we are going to be implement a deep learning based artificial neural network. So first of all, we are going to be discuss about like today's agenda, what we are going to be cover. So I'm just sharing this next slide. So our today's agenda is, first of all, we are going to be understand about the neural network, introduction part of neural network, what exactly neural network is, what is artificial neural network, and after that we will also understand the difference between biological neural network and artificial neural network. After that we will understand how like neural network works, what are the different type of activation functions that we gonna apply on neural network. Also we understand how does like neural network learns. So what is the working procedure in that, like how neural network learns from the data. Also understand the gradient descent optimization technique. Once we discuss all these stuff, we will move on to the practical part of artificial neural network, where we are going to be build a deep learning based artificial neural network model. And also we are going to be evaluating, improving, and tune the artificial neural network, and also test it whether we are getting a correct outcome or not. Today we are going to be take one case study that is for bank customer churn, where we have to check whether a bank customer will be stay with the bank or not. So now I'm going to be proceed with the neural network. So I'm just change the slide. So first of all, we are going to be discuss about artificial neural network. So with the advancement of machine learning, artificial intelligence has a very high chances of creating so many good applications. So in that case, deep learning is considered to be the most advanced technology that is built to solve the complex problems that use massive data sets. So we are going to be understand first the what is exactly the neural network is. So neural network is nothing but same like a human brain. In human brain, we have so many neurons, billions of neurons we have. In that, a neural network was basically built to mimic the functionality of the human brain. The human brain is a neural network that is made up of multiple neurons. Similarly, artificial neural network is made up of multiple perceptrons, where we have, so here you can see with this example, here we have two different images as an input, one for the dog, one for the cat. This is like input layer in neural network. These are the weights of the neural network layer. In that we have one hidden layer, and after that hidden layer also we are having a weight, and then we are getting an output. So we will discuss each layer one by one, and also understand that how neural network architectures basically work. So if suppose in this neural network, if I'm giving input as an dog, it will goes first as an input, and their weight, respective weights will be there. It goes under the hidden layer, and after hidden layer, there will be an activation function. With the help of that, whatever the resultant output which we will get after the activation function, after applying the activation function, we will get the outcome. So here we are giving an input as dog. So after it is going on to the neural network layer, we are getting an output as dog. So neural network consists of three different layers, such as input layer, hidden layer, and output layer. So understand the topology behind the artificial neural network. It basically follows the feed-forward network, which consists different type of layers, which we are going to be discussed now. So very first layer of artificial neural network or a neural network is input layer. So as the name suggested, this layer accepts all the inputs that is provided by the user. So if I am giving an input as in dog, so it will pose and feed onto the neural network layer. Based on the neural network architecture, we will get the output. Suppose if I am just giving the input as apple as a fruit to the neural network layer, if my model is trained through the neural network, we will get an output as apple in that case. So input layer is basically accepting all the inputs that is provided by the user or by the developer or by the programmer. Second important layer in neural network is hidden layer. So hidden layer is what? It is between the input and the output layer. That is a set of layers that known as hidden layers. In this layer, we are going to be perform a computation which result is as an output. So whatever the input we are feeding, that input goes with their respective weights. That weights goes on to the next hidden layer. And if we have suppose multiple hidden layers, so according to this example, we have two hidden layers. So it will goes on to the first hidden layer. After that, it will again update the weight and goes on to the next hidden layer. Once after it reach to the next hidden layer or the last hidden layer, then it will goes on to the activation function. And once the activation function will apply, we will get the resultant output as per our input. So in that way, the final layer is basically as an output layer. So output layer is nothing. The input goes through a series of transformation via the hidden layer, which finally results in the output that is delivered by this particular layer. And this layer is known as output layer. So before we get into the depth of neural network function, we also need to be understand what deep learning is. So deep learning is an advanced field of machine learning that uses the concept of neural networks to solve the highly computational use cases that involve the analysis of multi-dimensional data. So it automates the process of feature extraction, making sure that very minimal human intervention is needed in this case. So deep learning, as we already discussed on day number 1 or day first, like deep learning is an advanced subfield of a machine learning that uses the algorithm that is inspired by the structure of human brain, and that is known as artificial neural network. So artificial neural network, why like we need for deep learning and what are the limitations of machine learning, that is why we are moving on to the deep learning part. So machine learning was a major breakthrough in the technical world. It led to the automation and time consuming tasks. It helped in solving complex problems and making the smarter decisions. However, there were few drawbacks in machine learning itself that led to the emergence of deep learning. So what are the limitations of machine learning and why deep learning comes into the picture? So it is ML is unable to process high dimensional data because machine learning can process only small dimension of data that contains a small set of variables. If you want to analyze or containing more than hundreds of variables, then machine learning cannot be used in such type of cases. Feature engineering is also manual in machine learning. If we are going to be considered a use case, you have 100 predictors. 100 predictor means 100 inputs or 100 columns as an independent feature. And you need to narrow down only the significant one. So to do this task, you have to manually study the relationship between each of the variable and figure out which one are the important for predicting the output. So this task is also very tedious task and time consuming for the developers to building a model for predicting some outcomes for particular use case. It is also not ideal for performing object detection and image processing tasks. Object detection basically requires high dimensional data. Machine learning cannot be used to process image data sets because it's a high dimensional data. Anyhow, we can do that. But if we have a huge amount of data, in that case, with the help of machine learning, we cannot process. So in that case, we have a deep learning. With the help of that, we can deal with image type of data with the help of deep learning, convolution neural network, and also different techniques that are available under the neural network. I will give you one example for the deep learning use case. I hope you all are aware about PayPal. So I just want a quick confirmation from the respected faculties present here. Like, I hope you all are aware about like PayPal. Can I get a quick response once in the chat? Yes, correct. Okay, fine. So PayPal basically processed over more than $300 billion payments from around like 1 to 1 billion transactions by its more than 200 million customers. So it uses the vast amount of data to identify possible fraudulent activities, among other reasons. PayPal basically provides a payment gateway. So with the help of deep learning algorithms, PayPal mine the data from their customer purchasing history. And in addition to reviewing the patterns of likely fraud stored in its database to predict whether a particular transaction is fraudulent or not. So as we know, like if we are utilizing the online services, online payment services as well, there are chances of synthetic persons as well, which means that there are chances of fraudulent activities with your bank account, with the payment gateway and others as well. Because we are having an account, and for PayPal, if we talk about, so suppose there are multiple account holders, and the account holders having like their credit card, their account details, their phone number is registered. So the company has been relying, so company has to stop or reduce the chances of fraudulent activity. So what they are doing is right now, they are relying on the deep learning and machine learning technology from last few years. Initially, the fraud monitoring system or fraud monitoring team of PayPal, they are using simple linear models. But over the years, the company basically switched to more advanced machine learning technology that is called deep learning. So simple linear model is basically capable of consuming around like 20-30 variables. However, with deep learning technology, one can run thousands of data points. Therefore, by implementing the deep learning technology. So PayPal can finally analyze millions of transactions to identifying any fraudulent activity. If any fraudulent activity is detected, in that case, they quickly block the cards, block the bank account. So in future, the fraudulent activities will not happen for that particular account. So they have a dedicated team who's mainly focused on to detecting the fraudulent activities. Now, I hope you understand with this example. If still having any queries, so you can ask. I hope it's clear with this example. Yes, I will tell like what is the difference between all the layers. I will come into all the layers one by one. Now we need to be understand the next important thing. We will come up again into the upcoming slides also. Now, what is biological neuron? It's very important. We are talking about human brains and all. But first of all, we need to be understand what is biological neuron and artificial neuron. So I will combine both the things and explain you. Artificial neural network refers to a biologically inspired subfield of artificial intelligence that modeled after the brain. ANN is usually a computational network that is based on the biological neural network that construct the structure of the human brain. In our human brain, there are neurons, billions of neurons are presented there. Artificial neural network also have neurons that are linked to each other in the various layers throughout the network. And these neurons are basically known as nodes in artificial neural network. So artificial neural networks is basically derived from the biological neural network that develops with this human brain structure. Here you can see we have a structure of biological neurons where we have dendrites in a brain, neurons, cell body is there, was there, axon and synapses. So this is basically an example of biological neural network. And in that biological neural network, we have dendrites, we have cell body, we have axon, and we have synapse. Based on this model, artificial neural network created. So how artificial neural network is looks like, and I will show you the comparison between both of them. So here you can see, this is our brain, which having a number of neurons, which is connected throughout the network. And we are talking about like what is artificial neurons basically. In that artificial neuron, we have an input layer, we have uh, weights also, we have nodes, we have activation function, and we have output layer. So here you can see we have an input layer, we have the respective weights for these inputs, weight 1, weight 2, weight n, and also we have an activation function, and we are getting an output, and this basically known as the node. What exactly node is? It is a summation of put, and it is a summation of multiplication with weights and their respective inputs. So input 1, suppose I1 multiply with W1, I2 multiply with W2, and IN multiply with WN, and summation of all will be as node that will be goes on to the next layer, and after next neural network layer, and move towards the activation function. And whatever the output which we are getting after applying the activation function, that will be the desired output for particular channel. So which type of output basically neural network deals? It is in continuous in nature, whether it is in continuous in nature, binary, binary type of data. Binary type of data means like yes and no, true and false, or approve or disapprove, accept or reject. Such type of data is known as binary. Continuous, like predicting the salary, uh, predicting the profit of particular organization. And categorical data is containing like more than two classes. Like suppose if we want to identify like which student in a college is a good student, average student, excellent student. So this is an example of categorical data. So these type of output, basically we are going to be deal with the neural network. So here, artificial neuron is also basically known as the perceptron. We will discuss about this thing as well, but exactly perceptron is, and in that we will understand the perceptron is nothing but which contains only a single layer, and directly we are getting an output that is known as perceptron. So we are talking about these inputs, baits, activation function. Artificial neural network that is inspired by the biological neurons. In that, basically, we have inputs like suppose x1, x2, xn, and weights we have like weight 1, weight 2, and weight n. And after that, this node is basically a summation of all the respective weights along with their inputs. And that goes on to the activation function. Once the activation function will apply on that, we will get the final output. I'm audible or not? My voice is clear? Okay, fine. It's clear, correct? Now, this is the difference between the biological neural network and the artificial neural network. In biological neural network, we have dendrite, synapse, axon, or cell nucleus, or soma, you can say that. In artificial neural network, what we are seeing, soma is basically known as node, or you can say that nucleus, cell body we have. So cell nucleus is basically known as node in artificial neural network. Dendrites are our inputs in artificial neural network. Synapses are nothing but the baits or the interconnection between the neural network. And axon is the final outcome of the neural network. So artificial neural network, it is basically have an option to understand the things and make the decision like human, and the artificial neural network is designed to behave simply like interconnected brain cells. So there are around like billions of neurons in the human brain, and each neurons has an association point somewhere in the range of lakhs. And in the human brain, the data is stored in such a manner that to be distributed, and we can extract more than one of the data when necessary from our memory parallelly. So as a human, we think a lot of things parallelly. We are thinking a lot of things parallelly, basically. Like suppose I just want to write a code for someone. And also in my mind, there is an like PPT is also there and data set is there. So many things are there, but parallelly, I am able to think all these things. This is the same thing which we need to be feed into the neural network to perform the parallel task as well. So how it is possible? It is possible with the help of neural network. Now we need to be understand. After this, we need to be understand like the network basically. How does this perceptron work? So first of all, we need to be understand the input layer. Input layer, as I told you, like different types of formats we are having. Different type of format like image data. We have like we have a continuous data. We have binary type of data, which we are feeding into the neural network architecture, and based on that, we will get an output. Yes, I will come like activation functions, nodes, and everything. Now we need to be understand what exactly perceptrons and how does a neural network work. So we need to be break down it into different basically types such as like perceptron. So what exactly perceptron is? Perceptron is nothing but a single layer neural network that is used to classify the linear data which contains input, weight, and biases. Summation function. This I am talking about. What exactly it is? This is a summation function. Summation function is what? An addition of input, multiplication of input 1 into weight 1 plus addition with input 2, weight 2, input n, and weight n. In that case, we are going to be perform a summation function. So firstly, we need to be understand what is input basically. So input that receive from the input layer and that are multiplied with their assigned weights. I'm talking about this weight, which is multiplied with this. So the multiplied values are then added to form the weighted sum. Whatever we multiply, like input and weight we multiplied, after that we are getting a weighted sum. And the weighted sum of the inputs and their respective weights are then applied to a relevant activation function based on the problem statement. The activation function maps the input to the respective output. Yeah, I am coming into the weight now. Now, what is weight? We are talking about weights from a few minutes. So, weight and bias in deep learning. Why do we assign weights to each input? This is the question. So, once an input variable is fed to the network, a randomly chosen value is assigned as the weight of that input. And the weight of each input data point indicates how important that input is in predicting the outcome. Suppose, based on the weight 1, it will decide whether input 1 is important for predicting the outcome or not. If suppose weight 2 like weight 2 is important or not, if weight 2 is like weight 2 value, the weight of this indicates that input is then predicting the outcome or not. So but exactly the meaning is, based on the weight it will decide whether this input is important or not. Then only it will refer to the next layer of the neural network. Input refers basically input receives input are basically the multiplied with their assigned weights basically. It's an input is suppose like cat, dog. These are the different kinds of input we have. So we need to be checked like whether these inputs are important or not. That gonna multiplied with their respective weights, and based on this that weighted sum, it will check whether this particular weight is important or not. Yes, weights are the random values. Weights are the random values. Yes, input may be binary number. Yeah, input may be of any kind. No, weights, we are not assigning weights, are randomly assigning. We have one parameter called like kernel initializer where we have right like random uniform. So it means that randomly it assigns the weights. This is the thing which we need to be keep in our mind. When the randomly weights assigned, we need to check whether our activation function provides the resultant output or not. Weights are basically the coefficients of the equations which are trying to solve the negative weights that reduce the value of an output. When a neural network is trained on the training set, it is initialized with the set of weights, and these weights are optimized during the training period. These weights which we are talking about, these are optimized during the training period, and it will find out the optimum weights that are produced. So weights are essentially reflecting how important if input is. It is based on the weights only, we will decide whether this input is important or not. So if there is a positive relationship between, suppose I will give you one example. Let's assume you are predicting the price of a car in dollars. Okay. You understanding that the price of a car is dependent on the year it was made and the number of miles or kilometers it has driven. So let's assume that your hypothesis is that higher the year of car, the price of the car is increased, and subsequently, the more the car is driven, the cheaper the car basically. Higher the number of years of the car, the price is increased, and the the more the car is driven, the cheaper the car it is. So this example should help you to understand there is a positive relationship between the price of the car and the year it was made, and there is also negative relationship. What is that negative relationship? Negative relationship between the price of the car and how many number of kilometers the car has been driven. So as a result, we expect to see positive weights for the features that represents the year and negative weights for the feature that represents the miles or the kilometers. So what we can do in this case, we can go with the positive. So in that ways, we will decide the weights. Weights we are not assigning; it is randomly assigning the weights, and we are following the feed forward network in the artificial neural network. I will come to the back propagation method where you can understand like how we can update those weights, and based on that we will get the correct outcomes. So with weight, there is a bias. Yes, I'm coming to bias also. Bias is simply a constant value that is added to the product of the inputs and the weights. Bias is utilized to offset the result. Bias is shift the result of activation function towards the positive or the negative side. Based on the bias, it will decide whether it will goes for the positive side or the negative side. Imagine the scenario, one more scenario. Let's assume you want your neural network to return 2, 2 as a value. I'm talking about 2 number. When the input is 0, as the sum of product of weight and their input is to be 0. If suppose my input is 0, whatever the random weights are there, 1, 2, 3, 4, 0 point something, if I multiply with that input, I will always get 0. I will always get 0. So as the sum of the product of weight and input is going to be 0, so how will you ensure the neurons of the network returns 2? Can you please tell me how will you ensure the neuron of the network will return 2 in this case? If suppose your input is 0, that will be multiplied with the random weight, suppose 0 0.1, 1, 2, whatever the number of weights are basically. You will get 0, correct? So in that case, you need to be add bias of 2. So if we do not include the bias, then the neural network is simply performing a matrix multiplication of the inputs and the weights. So the addition of bias reduces the variance and introduce the flexibility and the generalization, better generalization to the neural network. So bias is essentially the negative of the threshold. Therefore, the value of the bias controls when to activate the activation function. Bias controls when to activate the activation function. So that is why weight and bias will also be there. I'm coming into the activation function also, so you will get the clear understanding about it. Now we are talking about this. So what is the working? So we already discussed. Now with this example, you will understand. Suppose we have x1, x2, x3, x4. These are the number of inputs we have, and with their associated weights, weight 1, weight 2, weight 3, and weight 4. In that step 1, what happened? As I told you, first of all, here you can see initialize the weight nearest to 0, but not 0. But we are always assigning, automatically it is assigning the random weights that will be multiplied with their respective weights, and their respective sum will be taken in this case. So how it is performed? X1 multiply with W1 plus X2 multiply with W2 plus X3 multiply with W3 and X4 multiply with W4. So this is the step 1 where all the summation with their respective inputs and their weights that goes on to the step 1. This is step 1 you are referring here. Initialize the weights. Inputs are multiplied with their respective weights and their respective sum. The sum is passed through an activation function to get the resultant output. After this, step number 2, here you can see one symbol called phi, which represents the activation function. So this particular sum, the weighted sum of input is going on to the next step, and the next step is called activation function, where we will pass the weighted sum of the input. So here you can see the sum is passed through an activation function, and after this step, we will get the output. So in the step number 3, we will get the final outcome. In this particular step, we will get the final outcome. So hope it's clear till now. Summation function is nothing. Once the inputs are assigned some weights, the product of the respective input and their weights is taken, and adding all these products give us the weighted sum, and this is done by this summation function. This summation function will apply after we are getting inputs and their weights, respective weights. Yeah, after input layer, it will, in an input layer also we have some weights. Then it goes on to the hidden layer. In hidden layer, again, the same operation will perform. If there is only single hidden layer, then directly it will apply the activation function and we will get the output. If multiple hidden layers are there, then again in the next step, it will check the updated weight for that particular hidden layer. Then it moves on to the next hidden layer and again update the weights and again goes on to the next step. Once it reach the activation function will apply on the weighted sum, that is called summation function. In summation function, we applied activation function and we will get the desired output. And the main aim of the activation function is to map the weighted sum to the output. And activation functions are basically of various type, which we are going to be discussed now. So till now, I hope it's clear. Now, I hope you understand with this example how weight is important. If you want, will having loan affects the salary? This is the question. If you are applying for job in any particular organization, so suppose you have an experience. Based on that experience, there are chances that you will there are like higher number of chances you will be shortlisted. But loan will affect the salary. Will affect the salary. Just tell me. If you selected in any particular organization, experience and your skill sets are there. Based on that, salary will be decided. If suppose you are also having a loan, suppose we are taking an example as 10 lakh rupees loan. So will this affect to your salary in any organization? Loan will affect the salary? No. So what does it mean? It means this weight is not important for predicting the outcome. Loan will not affect the salary. So it means that this weight and this input is not important. This we are talking like few minutes back, we are talking about this. Like which weight, based on the weights, it will decide whether the input will be select as an input feature or not. So in this case, experience is taking as an input, but loan we will not, because loan will not affect the salary. If skills are there, suppose there are one more we are adding, suppose skills and weight 3. So will skill affect the salary? Skills affect the salary? Yes. Your previous salary is also affecting the salary or not in new organization? Yes, correct. Your previous designation is also affecting the salary or not? If suppose you are selected in any organization, if any candidate profile got shortlisted, interview got cleared, everything is there. Experience is important, skills are important, loan is not important. Previous designation is important. Previous roles and responsibilities, previous projects, what they did before. So these are the important. So whatever is important, that will be decided by the weight. So weight will decide like whether this input is important or not. So in that way, like that is why weights are important. So I hope now it's the clear picture for you're getting the clear picture for the weights. Yes, it is. So you can see here, theoretically weights determine the importance of the inputs, and mathematically weights are just slope of line. In mathematics, we have a slope of line. No? So in that, basically, it will identify the importance of the inputs. Now I'm taking one example. I'm considering a scenario where you have to build an artificial neural network to classify the images into two different classes. Class A that contains non-diseased leaps, and class B containing disease leaps basically. So how do you create a neural network that classify the leaps into diseased and not diseased crops? So the process always begin with processing and transforming the input in such a way that it can be easily processed. So in our case, each leaf image will be broken down into basically the pixels on the dimensions of the image. Then the image is composed pixel by pixels, and these pixels are represented in the form of matrices, and that are fed into the layer of the neural network. So just like our human brain, we have a neurons that help in building and connecting thoughts. ANN has perceptrons. ANN has perceptron that accepts the inputs and process them by passing them from the input layer to the hidden layer and finally to the output layer. So as the input is passed from the input layer to the hidden layer, an initial random weight is assigned to each input. Suppose we have 10 inputs. So 10 randomly weight assigned to each inputs. And the inputs are then multiplied with their corresponding weights, and their sum is sent as input to the next hidden layer. That will become an input for the next hidden layer. The same operation perform onto the first hidden layer, suppose. Whatever the output which we are getting, weighted sum which we are getting, that will be an input for the next hidden layer. So in that way, the process is going step by step. And here a numerical value called bias is assigned to each perceptron, which is associated with the weightage of each input. So each perceptron is passed through activation. Yeah. So that determines whether a particular perceptrons get activated or not. So an activated perceptron is used to transmit the data to the next layer. In this manner, the data is propagated and forward propagation through the neural network until the perceptron reach the output layer. In that way, it is going on. No, slide number 12 I am right now. I'm giving you one example. So now we need to be understand. We are talking about from very curious about like activation function. And we are talking about like activation function from the beginning, basically. We are applying the activation function and all. So now we need to be understand what really happens in neural network and why activation function is needed. It maps the weighted sum to the output as you said. Yeah. So here you can see which type of data it is. If I want to separate this data, is it possible for me to separate this data? Anyone can please tell me, any participants? If I want to separate this data, so how can I separate? But how? Circle, if I perform circle, anyhow red circle will be there. It's a non-linear separable data. It's a non-linear separable data. We cannot directly fit the best fit line here. Or even if we are going to be create a circles as clusters. So anyhow, green points will cover with the red points. And that is not the correct thing. So this is the non-linear separable data. Data points are not linearly separable. So what we need to do is, when we are talking about like higher dimensions, so in that case, we need to be separate the data linearly. So what we need to do in this case? We have a 2D space right now. We can apply the mapping function here. We are applying the mapping function that converted into 2D space to 3D space. Now in the 3D space, it is easy for me to identifying the category green and the red category. Two different categories I will be able to identify easily. So what I did here, I have to apply the mapping function. When I am applying the mapping function into x1, x2, so one more dimension will be added, and that is known as the 3D graph you are able to see. With the help of this hyperlink, all the red data points goes down to the hyperlink, and the green categories on the top of this hyperlink. So this is how I linearly separate this data. So here you can see activation function is used to transform non-linearly separable data to linearly separable data. So which help us to perform more complex tasks. So this is a complex task. So such type of complex task, if we need to be performed and want a good outcome, basically to solve such type of complex problems, we need to use an activation function. And activation function is nothing but a mathematical function that takes input and produce the output. The function is activated when the computed result reaches the specified threshold. So how we are applying? So when we are talking about output, so in the previous slide, if you are able to see, in previous slide, you are able to see there is an activation function we applied into the summation function. Activation function where we have, if I will give you an example, like x1 w1 plus x2 w2 plus x3 w3 plus x4 w4, and in that what I am going to do is I am going to apply the activation function. So as an instance, here you can understand what are the instance. If the inputs are x1, x2, x3, x4, or xn, and weights are basically weight 1, weight 2, weight 3, or weight n, then a weighted sum is computed. With their subsequently bias will be added to that weighted sum. And finally, the computed value is fed into this activation function in this second number step. So think of the activation function as a mathematical operation that normalized the input and produced an output. So the output is then passed forward on the neurons to their subsequent layer. So we are talking about like activation functions. So firstly, we need to be understand what are the thresholds. So the thresholds are predefined numerical values in the activation function. And activation function can add non-linearity to the output. We are talking about activation function. In that, this can add the non-linearity to the output. And this feature of activation function makes neural network to solve non-linear problems. Non-linear problems are those problems where you cannot directly find out the linear relationship between the input and the output. So to handle such type of complex tasks, number of activations functions basically introduce, which can be configured the given input. So there are different type of inputs. One more important thing, if neural network without an activation function is just like a machine learning linear regression model if you don't have an activation function. So these are the bullets which you need to be keep in your mind. So there are different type of activation function. So different type of activation functions are there, such as like threshold function. Threshold function is nothing but an activation function which has a specified range. So what is that specified range? It is if the value is less than 0. If the value is less than 0, it will always treat it as 0 in this case. Just go back, sir, to the previous slide. Yeah. Okay, fine. So till now you all understand, all the participants understand or not? Till now all the participants understand? Okay. So we have a different type of activation functions here. So different type of activation functions such as like threshold function we are talking about. If any value is greater than 0, it will always treat it as 1. And if any value that is less than 0, it is always treated as 0. So threshold function is nothing but we can decide the threshold. Suppose if I decide the threshold as 0.5, whatever the output which we are getting, the value which we are getting more than 0.5, it will always treat it as 1. And if below than that, it will always treat it as 0 in that case. So in that case, in such type of problem where we have to find out the solution in between like 0 and 1, so in that case we will go with the threshold functions. Now we have like different type of function. I will show you. These are the different type of activation functions we have. Like threshold function, Relu function, softmax function, sigmoid function, 10H function. And threshold function is also known as binary step function. It is also known as binary step function. It is based on activation function, which means after a certain threshold, neuron is activated, and below the said threshold, neuron is deactivated. So with this example, the activation function can be used in binary classification. As the name suggested, binary step function, or you can also say that like a threshold function. Yeah, it is also known as a binary step function. So this activation function can be used in binary classification. Now come to the next activation function, that is known as Relu activation function, which is widely used activation function. So this function output for the positive inputs can range from 0 to infinity. But when the input is 0 or it is a negative value, then function always give the output as 0 in that case. If we talk about Relu activation function, that is called rectified linear unit. Yes, based on the data. So it like widely we are using Relu activation function in dense layer. And if we talk about for the output, suppose if you have a binary type of data. So in that case, we will go with the sigmoid function because it deals better in the binary type of data. If you have like multi-class classification, then in that case, you will go with the softmax function. Yes, we have Licky Relu also. We have 10H function. We have a non-linear activation function also. That is, and again, the example of 10H function, Relu, Leaky Relu, these are basically known as non-linear activation function. So linear activation function and non-linear activation function. So currently we are talking about non-linear activation function. In that, basically we have, yes, we have ELU also, we have GELU also, Leaky Relu we have. So sigmoid function is the function that take a probabilistic approach and the output range between 0 and 1. And it normalizes the output of each neuron. However, sigmoid functions makes almost no change in the predictions for very high or very low inputs, which ultimately results in the neural network. And this problem comes into the picture, and this problem is known as vanishing gradient problem in this case. We will discuss later about this. Now we talk about like 10H function. So 10H function is also known as hyperbolic tangent function. It is almost same like as a sigmoid function, but it's slightly better than that. Why? Because its range start from -1 to +1. In sigmoid, if the outcome is less than 0, it will always treated as 0. But in case of 10H function, the range in between like -1 and +1. And 10H is also facing the problem of vanishing gradient problem, just like sigmoid. We will discuss about that. We have leaky Relu also. So leaky Relu is basically prevents the Relu problem, whatever the Relu problem which we are getting. What is the range of sigmoid? 0 to 1. It's 0 to 1 sigmoid. Softmax generally used for multi-class classification. It's depend on how many number of classes you have. More than 2 classes, we prefer softmax function because softmax function works well for multi-class classification data. So if we have a multi-class classification, softmax is basically an extension of the sigmoid activation function as well. Softmax function adds the non-linearity to the output, and it is mainly used for classification type of problem. So softmax function, we have like, suppose if you have like 10 different categories. So what you need to do, it range started from 0 to the number of categories you have. Its threshold function is basically comes under the linear function basically. Its sigmoid function is a non-linear function. For non-linear data, we are basically deal with sigmoid function. Yes, in general, when we are moving on to the dense layer, we applied most widely we applied Relu activation function because it has the different structure. Like if the value is less than 0, it is always take it as 0. If the value is more than 0, in that case, it will compare in between 0 and that particular value. Whatever is maximum, that will be treated. And in output layer, basically we have to change based on the problem statement. We have to change. Output layer for classification, yeah, multi-class classification, we go with like softmax. If we have a binary type of data, that is also a classification problem, we will go with a sigmoid function in that case. Mostly we use Relu activation function in the hidden, like in the dense layers basically. Because it comes under the non-linearity to the output, and the range of Relu activation function is from 0 to the infinity. Now come to the next slide. So how does ANN learns? So what is the main purpose behind it? As we know, like input layer are there, then we have weights, biases, hidden layers, and after hidden layers, the summation of all the weighted sum basically, and that goes on to the activation function. And after that, it will apply the activation function onto the weighted sum, and we will get the output. So here you can see we have one example which contains like different fruits such as like banana and oranges. So if I want to separate this data, I will get some error. Error means we are not predicting correct outcome. And what is the main purpose here is? Our main purpose is to reach out the minimum error into the neural network. So how do we reach out? So in that case, with this example, you can see we are classifying this as an orange, and this below this line we are defining as the banana. So we have two different fruits right now. So how many number of errors we are getting in this case? Can anyone please tell me? 3, correct. So we are getting error as 3. Now in the next iteration, what happened? Now can you please tell me like what is the error in this case? Now we are having an error as 2. After applying, like this is how like ANN learn. First iteration it will learn, okay, this is the different shape and these are the different shapes, because it is banana is in the different shape, which is in yellow color, orange is in orange color, and spherical in shape, and both have like different taste also. So we are classifying, we need to be reach out to the minimum error. In the next iteration we are getting an error as 1. Now what is the next thing? We need to be find out the local minimum, which means local minimum error we will get. So how do we get? Next iteration again we perform, and we will be able to classify in this particular point what we reach participants. In this particular point we are getting minimum error, we can say that. If suppose no error, you can say in this particular point we are getting minimum error, but we are getting minimum error here. So what is the main purpose in second iteration? How error as 1? There is an error as 2. Sorry for I think there is mentioned basically error is 2 in this case. Here it is 3. Like we are classifying this banana will goes on to this, so this line is deprecated basically. So in this case we are getting an error as 2 basically. Here again I will tell again. Here we have a banana and oranges. There are 3 oranges and 3 bananas. We are getting error as 3. In this case, this line basically comes after this banana actually. So there is an issue with the PPT. I think this slide is there is an issue with this line. So sorry for that. But yeah, here we can say that if we are classifying in that case, so again 3 errors. Again 3 errors. Here again 3 errors. 2 for oranges and 1 for banana. So again 2 plus 1, yeah, Himasri ma'am, yeah, it's correct. Like 2 plus 1, that is 3 again. If we have this line after this banana, so we will be getting error as 2 in that place. And last one, here we are getting minimum error. So now it's clear. Now it's clear. because we have to classify into different categories. That is why error is equals to 3 in the first place. Once again, I will tell once again. With this example, we have two categories of data. One is banana, another one is orange. Okay. In that, 3 bananas and 3 oranges comes under top of that line. So how many number of errors? Because we need to be classified into two different categories, one for the oranges and another one for the bananas. All bananas here. So how many number of errors are there? 3 oranges placed into this place. So that is why we are getting an input output like error as 3 in this place. In next iteration, we are able to see 2 oranges with 2 banana and 2 oranges with 1 banana. So how many number of errors are there? 2 oranges in the banana place and 1 banana into the orange place. So 2 plus 1, that is 3 again. Here in this place also 3 errors. If suppose this banana is placed here in the top of that line, so in that place we are getting an error as 2. After the next iteration, we are getting while we are training, so data is moving on to like one iteration, next iteration, third iteration, fourth iteration. In that way, we are going to be train the data. So that is why the inputs gonna change. It will check with all the inputs, data points, and based on that, it will identifying the minimum number of losses or minimum number of error in case of this. So our main purpose is to achieve the minimum errors. So this is how like we are achieving the minimum errors in this case. Now, here you can see perceptron or artificial neuron is trained in such a way that it's find a line which separate the different classes by adjusting the weights and biases. So in every iteration, weight and biases got updated in every layer, and based on that, we will reach to the minimum error. Yes, we have an optimizer in this case. I'm discussing about that thing. Yes, gradient descent is used to avoid this. So we are talking about that thing. So we are taking one example here, where one student is there whose rank he is secured as 2, number of hours of study is like 12, pass percentage 84, and exam like they are getting 87. So what we are going to do is, this is our input 2, 12, 84, and based on that we need to be predict the outcome. This is the actual outcome which we have 87. This is the actual outcome in our data set. Now in this, random weights are assigned 0.2, 0.6, and minus 0.2. What will be the next next step, participants? What will be the next step? Weighted sum, correct. So what happened in this case? Summation will perform and we will get the weighted sum. So summation function be applied into this data. Then after it goes on to the activation function. And after activation function, we will get the output. Yes or no? This is the architecture which we will get based on this data we are feeding as an input 2, 12, 84. We have to predict the percentage of that student in examination. In that we have a random weights. Random weights basically multiplied with their respective inputs, and summation function will applied on that. That summation function goes on to the next step where activation function will apply, and after that we will get the outcome. Now here you can see we are having the weights and their respective inputs. So here it is multiplying like 2 with 0.2, 12 with 0.6, 84 with 0.2, and we are getting an summation of these inputs basically. Yeah, these are the just random numbers basically, random weights assigned in this case, and we are getting an outcome as 23.6. So this is the summation function. When we applied into this particular data, we are getting an outcome as 23.6 in this case. Still not clear? Till now it's clear? Okay, that's good. Now we understand in the next slide. So here we are getting 23.6. That is the weighted sum which we are getting. We are not assigning, I'm not assigning these weights. These are the random weights. Automatically it's assigned. We have one parameter called like kernel initializer. Under that we need to be passed random underscore uniform. With the help of that, it will initialize the weight. Now in this summation function outcome which we are getting as 23.6, in that we applied Relu as an activation function. When we applied Relu as an activation function, we will get an output. So what will be the output in this case? Y bar is representing the predicted outcome. Y bar will be the predicted outcome, and our actual outcome is 87 based on this data. So is it the correct outcome? Is it the correct outcome? No. What we have to do now? What we have to do? This is the we are following the feed forward network right now. We are following feed forward network from left to right direction. We need to be adjust the weight. Yes. So what I need to do in the next iteration, we are getting this outcome, correct? So our cost is very high in this case. If you are going to be calculate the cost, so cost is very high in this case. So what I need to do is I need to perform error calculation. So we calculate that number like error basically 1 by 2. Y bar is 23.6, then 87 in a square of it to convert it into the positive, and we are getting the cost. So cost is very high in this case. So what I need to do, I have to perform back propagation. Why we perform back propagation? What is the purpose of back propagation? Anyone? Back propagation basically what we need to do is we need to somehow explain the model to change the parameters like weights, such that errors become minimum. This error we need to be minimized. Yes or no? To update the weights to attain the actual output. Okay. To decide if we need to increase or decrease the weight. Correct. So what we need to do? First of all, we calculate the error. How far is our model output from the actual output? Minimum error means check whether the error is minimized or not. We have to update the parameter in this case. Parameter tuning, correct. So we need to be update the weights. Update the parameter. If the error is huge, in this case, error is very huge, then we need to be update the parameter, which means weight and biases. After that, again check the error, repeat the process until we reach the minimum error. So what we need to do in this case, we have to perform a back propagation. So back propagation we applied, the weights got changed. Now we are getting the optimized weight. After optimized weight, suppose we are getting an output as 87 or 86 also. So we are taking 86 or 87. Then again, Relu activation function be applied on that data, and we are getting an output. This is the predicted output which we are getting right now, and this is the actual value, which means we are reaching to the minimum number of errors. Now we are having a minimum error. So in this case, once the errors become minimum, you can feed some inputs to your model and it will produce the output. So now you know why we need back propagation, or why and what is the meaning in the meaning while training a model. So back propagation algorithm looks for minimum value of the error function in the weighted sum using a technique that called like gradient descent. Yes, there is bias also. bias will be added in this case. Like bias will be there, and based on that, that will be applied into this function. Now, what is the solution for that? Like suppose we have different type of data and we need to be predict those outcomes. Explain back propagation once again. Yeah. In forward propagation, what happened? 0.2, this is multiplied and goes on to the weighted sum. That weighted sum goes on to the next step, that is called activation function, where activation function will apply onto that weighted sum. After that, we will get the output that is called the predicted output, where we compare with the actual output and calculate the error. If error is high, what we need to do in this case? We need to be apply back propagation. What back propagation did is, back propagation is basically used to change the weight and find out the optimum weight, which help us to reduce the number of errors and also reach out to the minimum error. So that is why we have to apply back propagation. So in that way, again, we are moving on to this way and update the weights. Once weights are updated, again, feed forward network will come into the picture. So in that way, the things got happened. So here you can see we have different number of inputs and we are having different outcomes basically. If we want to calculate this, like C1, I want to calculate for this C2, C3, C4, C5, C6. Different, like each data I have to check. In every iteration, we have to check with the each data. Yes. So every step we have to, like in C1, we are calculating and we are getting an output as 87%. In C2, we are getting an output as 72%. These are the actual outcome. So how we are performing for this particular data, which is available in this tabular format, we have to put into this neural network, and based on that, we are getting the errors. We are calculating the errors, and after calculating all the errors, we have to sum up and find out the final cost of this particular data. So this is how, like, we are calculating all the data cost, and sum of all the cost is basically known as the final cost. Final cost means that much amount of errors which we are getting into the model. Cost means error basically. Cost means error. Like suppose if you are getting 23.6, first time we are getting 23.6, and we are also having, but our actual output is 87. So there is a huge error in that case. So our main purpose is to reduce it. So how we can reduce? We have a solution. With the help of gradient descent, we can do that. With the help of that, we are going to be update the weights. Once we update the weights, so in that case, we will get the outcome. Clear now? Yes, these are the evaluation metrics basically, like root mean squared error, mean squared error. So these are the evaluation metrics basically for regression type of data. Now we are talking about the solution for that type of problems. So the solution is like gradient descent. What is gradient descent? Gradient descent is an iterative or optimization algorithm that help us, that is used basically for reaching the local minima of a given function. With the help of this method, we are minimizing a loss or a cost function of deep learning neural networks. Yeah, it's a random data we are taking basically. So however, it is used to not controlling. This method is basically proposed before the intensive development of the neural network and the deep learning techniques. So what is the functionality behind like gradient descent and why we are using it? So gradient descent, the concept of minimizing the cost of error, we have to optimize the weight. So in that case we will use gradient descent to optimize the weight. And there are different type like mini batch gradient descent, batch gradient descent, stochastic gradient descent. So different type of gradient descent are presented. In the case of gradient descent, so gradient descent algorithm iteratively calculates the next point using the gradient position and subtracts obtained value from the current position. So it basically subtracts the value because we want to minimize the function. We need to reach out to the minima, local minima. So in that case, we have to check with the learning rate of the neural network. Yeah, mini batch gradient descent is also there, stochastic batch gradient descent. So gradient descent methods basically choose a starting point that is called the initialization part. We have to calculate the gradient at particular data point. Then after we have our main objective is to minimize the error. We have to repeat this process till when we are reaching the minimum errors. So how many, like in that case, we are getting maximum number of iteration, because if I want to update the data, if I want to update the data for the previous example, which we take for a rank key secured, basically, in that case, how many number of iteration we need to be performed? We directly not we are getting in the next step as an optimized way. Maybe it will take number of iterations, 10 iteration, 20 iteration. So maximum number of iteration it will reach, and step size is small, like smaller than we have to check with the gradient descent. So starting point it will take, then gradient function we apply, then what is the learning rate, maximum number of iteration will perform, and then we reach the minimum error of the data. Now we have to understand, this is the main purpose which we are talking about, like we have to calculate the cost to be reach into the local minimum. Suppose this is the point where it is started, basically. Suppose this is the point from where it is started. So what happened in this case? We have to reach the local minima. We have to reach the local minima. So the best way to define the local minima or local minima, basically using the gradient descent, if we move towards a negative gradient or away from the gradient of the function at the current point, then in that case we will reach out to the local minima. So in this particular case, when we are moving on to this particular position, we will reach out to the local minima. In this particular way, which we are reaching the local minima. Now, suppose we are taking an example. Initially, the weight is in this particular position. Second one we are taking. Initially, my weight is in this particular position. Now, incremental step will come. Next iteration, it will goes on to this position. Next iteration, it will goes on to this position. Suppose we are reaching the best local minima in this position. So that will be the minimum cost of particular position. This entire is basically known as the derivative cost. This is the weight of data, basically. So the entire procedure is known as the gradient descent, which is also known as the steppist descent, which means that a step-by-step process is there. The main objective of using a gradient descent algorithm is to minimize the cost function using iteration to achieve this goal. So what we have to do here, firstly, we need to calculate the first order derivative of the function to compute the gradient or slope of that function. Then after, we have to move away from the direction of the gradient, which means if the slope increased from the current point, so learning rate alpha is defined, like learning rate alpha is defined in this case. So here it is a tuning parameter. In this optimization process, it will basically help us to decide the length of the steps. So cost function is defined as the measurement or the difference or the error between the actual values and the predicted values at the current position, and it also present in the form of single real number. So how does it works basically? So it is starting, suppose, from this point, as I told you. So in first iteration it will start from this point, it will goes on to the next iteration, then next iteration. When it reach to the minimum value, that minimum value is the point of convergence, which means where the cost function is reached to the minimum position. So in this particular point, we are reaching to the minimum position. Now we need to be understand different type of gradient descents are there. One is like batch gradient descent, mini batch gradient descent, stochastic gradient descent. So batch gradient descent we are talking first. So batch gradient descent is used to find the error of each point in the training set, and it update the model after evaluating all the training examples. So the procedure is known as the training epoch basically. So in that, there are some advantages of applying batch gradient descent because it produces less noise in comparison to other gradient descent, and it is stable gradient descent convergence. We have another gradient descent that is called mini batch gradient descent. So mini batch gradient descent is basically a combination of two gradient descent that is called batch gradient descent and stochastic gradient descent. It's divide the training data set into small batches. It divides the training data set into small batches. Then it will perform the updates on those batches separately. So while we are splitting the training data set into smaller batches or smaller chunks, it makes a balance to maintain the computational efficiency of the batch gradient descent and also the speed of the stochastic gradient descent. So it is very easier to fit into the allocated memory, and it produces the stable gradient descent results. Now we have talking about mini batch. So in that you can see we have like forward propagation and backward propagation we are applying in that way. So stochastic gradient descent, if you see, we are going step by step. Here stochastic gradient descent is gradient descent that runs one training example per iteration. So in this particular iteration, it reaches onto this position. In the next iteration, it will reach to the next position. Then again, it will, when it reaches to the final or the minimum position, that will be the final outcome. So stochastic gradient descent, it is a process of a training epoch, for example, within a data set, and updates each training example parameters one at a time. At one time, all the parameter will goes. So it requires only one training example at a time, and it is very easy to store into the allocated memory, and it also shows some computational efficiency in comparison to batch gradient systems. Due to the frequent updates, it also treated as a noisy gradient descent itself. So it can be helpful to find out the global minima, and also it escape the local minima. So this is how like we have a different number of data. So we apply forward propagation and the backward propagation. And this is, we are talking about, we have like input layers, multi-layer perceptron, where we have a weights also for this input layer. Then we have hidden layer also having their weights. After that, second hidden layer we have, in that it also contains the weight. And this is the final layer, suppose. Second hidden layer is the final layer. After that, we have to apply the activation function and we'll get the output. So in activation function, whatever the weighted sum which we are getting after second dense layer, that will be the final summation for the activation function to generate the output. So this is how like multi-layer perceptron works. So here you can see we have two different inputs and 28 weights basically, because we have inputs weights also, and we have like hidden layers weights also. So this is how like two inputs we are having, like x1, x2, which also contains their respective weights to predict the outcome. And neural network is basically, or a deep learning is used for dealing with such type of data like speech data, image data, unstructured data, structured data, and based on that we will get out. So I hope till now you all the participants understand. I hope till now every participants understand. Yes, gradient descent like backpropagation. Anyhow, we need to be reached to the like local minima in that case. Error rate is basically we are calculating the difference between the predicted outcome and the actual outcome, predicted value, or the difference between the predicted value and the actual value. So I hope till now it's clear, all the participants. Yeah, feed forward. Generally, we followed like in neural network, feed forward network. Back propagation is required in that case when we have to update the weights if our error rate is very high. So without wasting the time, we will move forward to the IBM cloud. So I'm just sharing my screen, the browser. So I just want from all the participants to come up into this page. So hope my browser screen is visible. Please give me the clear like confirmation once in the chat. Hope my web feed forward is basically in general it follows like input layer to the hidden layer to the second if multiple hidden layers are there, and after that activation function, and we are getting an output layer. So this is the feed forward network. When we are getting the higher errors, so in that case we have to update the weight. So in this case back propagation will come into the picture. So please log into your IBM cloud account. I'm requesting to all the faculties here, please log into your IBM account. In so many use cases, we have like back propagation. It is an optimization technique to update the weights. Now we are using optimizers. So please log into your IBM cloud account. Okay. So right now we are in the dashboard. Yesterday we created one service called Watson Studio. So how you can find out that service and where all the services are present in your IBM cloud account. So for this case, once I hope you all are in this dashboard. Platform. Just a minute, I'm just sharing the link. hope I'm audible. Sorry, I think there is some network issue. Hope my screen is visible and I'm audible to all. I'm audible to all. Please give me the quick confirmation once. Hope my screen is visible and I'm audible to all. Hello. Yeah, fine. Thank you. Yeah. So right now we are in the dashboard. We already created a service called Watson Studio. Now we need to be use that service. So how we can just click onto the left hand side top corner. We have a navigation menu. Click on that. Now we have an option called dashboard and resource list. So because that service we already created, so we need to be click on resource list. Once you click on resource list, once we click on resource list, so resource list page will be loaded right now. In the meanwhile, I'm requesting to the mentors, please share the data set with all the faculties. Please share the data set link once. Please share the data set link. Please share the data set link once in the chat. Yeah, right now we are in the dashboard. So how we can access the resources which we already created on IBM Cloud. So we have to click onto this hamburger menu in the top left hand side. Click onto the resource list. After click onto that navigation, click on the resource list. Once you click onto the resource list, you will be redirect onto that page where all the services which you created on IBM Cloud will be reflected. So here you can see in this particular page, we are having different options like name, group, location, product, status, tags, and others. So here we have an option called services and software. Here we have an option called services and software. Please click onto this option and you will get an option called Watson Studio, this service which we already created yesterday. So I'm getting an option under the resource list. Go onto services and software, click onto Watson Studio service. Click onto Watson Studio service. And we already shared a data set. So I'm requesting to all the participants present here, please download that data set the data set we are going to be use for building an ANN model. I will also explain which use case we are taking. So first of all, click on to the Watson Studio service, and then after we are moving on to launch the IBM Cloud. So please click on to this blue button, launch the IBM Cloud. Once you click on that, you will be redirected onto the next page where you will have an option. One pop-up will come. So please close this pop-up. We already created a project yesterday. So what you need to do is you can go with that project also. Otherwise, you can create a new project. So simply I'm just click on to work with the data, and I'm going to create an empty project now. So please click on create an empty project. Automatically, because yesterday we created a cloud object storage service that is used for storing the data. So which project we are talking about right now? ANN. So I'm just giving the name as ANN for the new project. After that, if you want to give the description, so you can give it. Otherwise, click on create button. Please click on create button. Create a project. Create an empty project. Once you launch your Watson Studio, please click on create a project. Then click on create an empty project and give the name of the project. So I'm giving the name as ANN. In the same case, you can also give the same name, or you can also you can change the name also. After that, we have to go on to the asset section. Yesterday I told you how to create the Jupyter notebook. So click on asset section. Click on this blue button called new asset. Once you click, one pop-up will come, and you have an option called code editor. Please click on code editor and click on the Jupyter notebook editor. So please click on Jupyter notebook editor. Once you click on that, you have to create a notebook. So just give the name as, I'm giving the name as AI day 3 ANN notebook. So in that case, like if you want to give the same name, otherwise ANN you can give. So this is the notebook name, and I want to utilize like 2 virtual CPUs and 8 GB RAM. If you want to change, you can also change the runtime from here. Yesterday I told you, we used 1 virtual CPU. Today I am going with 2 virtual CPU. Now after that, you have to click on create. So your notebook will be created on IBM Watson Studio platform. And I hope all the faculty present here downloaded that data set. After giving ANN, click on create button. Click on create. If it is not presenting, please refresh the page once. Please refresh the page. Yes, I am going slow. Once you all are in the same page, then only I will move forward. Yes, we will share the data set link again. Once you click on launch to the Watson Studio, I will show you once again. So I'm launching the Watson Studio. Once your Watson Studio will launch, you have to click on create a project and click on create an empty project. If you yesterday already created a project, so you can also create please click on to work with data. Once you click on work with data after launching your Watson Studio service, you have an option called create an empty project. Click on that, give your project name. Then after, Once it's launched, so you will be in this page. Sorry. Once your project will be created, you will be on this page. Once you create the project. After that, go to asset, click on this blue button with the new asset, go to code editor, click on Jupyter Notebook, give the name of that notebook, any relevant name you can give. Suppose you are giving ANN. So give ANN and click on create. Once you click on create, it will take few seconds, and after that, your notebook will be created and you will be on this page. So I hope all the participants present here are in the same page. Yes, I'm waiting for that. How many of the participants are in the same page and successfully launch the Jupyter Notebook under the Watson Studio? Login, done. No, done in Jupyter. Okay, that's fine. Looks nice. I hope you downloaded the data set also. So we have a problem statement. Sir, if possible, can you send today's class recording? Yes. Recordings will be uploaded into the SmartInternz educator login. You have to log in into the educator, click on externship, and then after click on the learning resources. And after that, you will be able to access the recordings. By default runtime, you can also go with that. Otherwise, you can go with 2 virtual CPU with 8 GB RAM. Yes, you can change the file name. It's a simple kind of thing which we do on we did on Google Colab or in Jupyter Notebook. The same kind of thing. Any name you can give. Not active, sir. After giving ANN, do one thing, Anita ma'am. You can go once again and launch the Watson Studio, and then create a project. Yeah, dataset link we already shared, and we will again share the dataset link. So today we are going to be predict the customer churn. We are going to be we are having a case study to find out whether a customer will stay with the bank or not. So we have a data set called churn modeling. The data set is for banking. So bank customer churn classification with neural network we are going to do, where we are classifying bank customers based on their previous bank activities that they will exit, which means leave the bank or not. So I'm just giving the heading for understanding purpose. Bank customer churn classification with ANN. I'm giving the heading bank customers churn classification with ANN, where we have to classify whether the customer will be exit the bank or not. So we have a data set. We have to import some libraries. So first of all, we have to import the library. So I'm just importing the library such as like import numpy as np, and we are importing pandas as pd. I want to run this cell, and after that, one more important thing, in Google Colab, in local system, we generally load our data set with pd.read_csv, and in bracket we pass the data set name. But right now we are using IBM Watson Studio service. Under that, we are having an asset called Jupyter Notebook. So how we load the data set in IBM Watson Jupyter Notebook? Shortcut to move on to the next line, just if you press shift plus enter, automatically new line will generate. Yeah, shift plus enter is the shortcut key. It will execute the selected cell and also insert one more cell. Yeah. Now in the right hand side, you will get an icon. You are able to see this icon in the right hand side top, 0100, 0100 icon, where you can find and add the data. So we need to be add the data, which means in general, in local system also, we need to be give the path and then load the data. Otherwise, if it is present in the same directory, we are loading the data set with the name of that particular file. We have churn underscore modeling.csv. We firstly need to be upload into Watson Studio. So where that file will be stored? That will be stored into cloud object storage, which we created yesterday. That is the default storage for IBM Watson services or for IBM Cloud. So what I need to do is I have to click onto this icon in the right hand side top 0100. If you click here, you will get an option, upload one file at a time, all the types accepted, 5 GB maximum file. So you have an option like drag and drop the file here or upload. So we already shared the data set. I hope you downloaded in your local system. If you are stored somewhere in your folder, so please click onto this option, this link, and after that select your data set from your local system and click on open. Once you click on open, here you need to be load the data set. Click onto this link. One pop-up will come. Select your data set wherever in which location the data set is presented. Select that, click on open, and it will take few seconds to load the data set based on the data set size. So I hope you all successfully load the data set, upload the data set, done. That's good. Now in local system, if I want to read the data set, I'm generally like df is equals to pd dot read underscore csv, and in the single quotes, I just need to be give the name churn underscore modeling dot csv. Is it the way we load the data set? And if we run here, we will get an error. Why? We are getting an error as file not found error. Why we are getting this error? Because we are utilizing IBM service. Under that, we need to be fetch the data from cloud object storage. So if you are directly going to be run in that way, or even if you are giving the path, so this will not work here. So what you need to do, you don't need to be write even a code here. I'm just commenting this just for giving you the insight about that. We cannot load the data set here directly, right? Like pd.read underscore csv, because we load this data, sorry, we load this data into the cloud object storage. So here you have an option, one drop down menu is come. Click on this drop down. You have two options, credentials, another one is pandas data frame. So please click on pandas data frame. Firstly, select the cell, click on insert to code, select pandas data frame, automatically code will be added. Automatically this code will be added. So what exactly it is? Click on this 0100, upload your data set. Once you upload your data set successfully, you have a drop down option, insert to code, click on this drop down. You have two options. One is for pandas data frame, another one is for credentials. Select the pandas data frame. Once you select the pandas data frame, in the selected cell, the code will be generated. Here it's automatically import the operating system and types library, pandas also, botocare.client and IBM Boto 3. So what are these? IBM Boto 3 library basically provide complete access to the IBM cloud object storage. So we have IBM Cloud Object Storage. So my option is streaming data object. I think please check with the file. How many of you are successfully load the data set? Participants, done. Please check with the dataset file. Done. Okay, that's good. So we have IBM Auto 3. We have this amount of code. What exactly it is? What is that function? In this function, what is that code exactly? So understand. IBM Auto 3 library, which provides complete access to the IBM Cloud Object Storage API, which contains endpoints. So here we have an endpoint URL. Endpoint URL means in which location the cloud object storage service got created. It is in the global. So here you can see s3.private of US cloud object storage. So this is in this particular location. Endpoint is also there. API key is automatically generated, and it goes pass into the IBM Auto 3 client. So what happened here is, and like it creates endpoint, API key, and the instance ID that must be specified during the creation of the service resource or low level client. So here the service instance ID is also there, instance. So this is an instance basically which we created. Under that we have IBM API key ID, endpoint for that. This is the token from where which we are using this service. API key ID. This is an automatically generated API key for this specific data set, because it is stored somewhere in the cloud object storage. For authenticate the cloud object storage, this API key is generated. It will identify with this particular URL. Once its authentication is successfully, then it's checked with the endpoint URL whether this particular cloud object storage service is created in this particular location or not. Then after, in body, the data set comes as a key, because this works as a key, and under that there is a bucket. Which bucket? ANN do not delete, which means I have this project called ANN. Under this bucket, under this project, I have this as an asset. If I will go back into this project now, I will get here. If I refresh, I am right now in ANN. If I refresh this page, ANN project, if I refresh this page, here you can see one more asset will added. So churn modeling is added now 6 minutes ago. 6 minutes ago. So this asset is come under this bucket, and that name is churn modeling.csv. After that, it will be checked with the this particular authenticate with this cloud object storage. After that, automatically the data frame variable is created. But right now, what I want to change it. So you can also change it. DF, in DF, I want to store it. It is easy for me to navigate. So I am just running this. So with the help of, here you can see pd.read_csv. Right now it's working because it authenticate this. After this body is also authenticate this data set is present or not. Yes, if it is present, directly we pass this body. So after that, you will be able to see here, we have a data set, large sample of the bank customers. This is the data set for the bank customers. So to make this data set, the bank gathered information such as the customer ID, surname, credit score, age, gender, tenure, balance, number of product, credit card or not, is an active member of the bank or not, what is their salary, and there are chances that they will leave from the bank or not. So after that, what is our main aim? So here you can see during a period of like tenure we have. So in that period, we have a month-wise data, suppose. So the bank observed if these customers left or stay with the bank. This is the main purpose. This is the main aim. So the main goal is to make an artificial neural network that can predict based on the demographical and transactional information that is given into this data set. If any individual customer will leave the bank or stay, we need to check the customers of the bank based on their probability of leaving. So what are the things we need to do? We first need to load the data set. We load it successfully with the help of pandas data frame that comes under Watson Studio. Churn modeling is not defined, error. How many of you are getting error? No error. Okay, that's fine. So I hope like you all successfully load the data set and also check the top 5 rows of data with the help of dot head function. That's cool. So now we need to perform exploratory data analysis. First of all, we need to understand how much data we have. So I'm just writing like df.shape function to check the data set. It's not a tuple, df.shape only. So df.shape, which means in this particular data set, we have 10,000 rows of data and 14 different columns. After that, we also need to check what are the different columns we have. So if you want to check the columns only, so just write df.columns, and directly if you run, you will get the information related with all the columns that are presented under this data set called churn modeling. So we have row number, customer ID, surname, credit score, geography, gender, age of a person, tenure, like how many months they are with the bank, balance, number of products, has a credit card or not, is he an active member or not, estimated salary of that particular person, and he or she will exit from the bank or not. Now, we need to check the data types of this particular data set. So how we will check? df.types, I just need to write df.dtypes. Basically, I want to check the data types. So df.dtypes, and here you can see we will get the information related with our data set. In that row number, like in 64, which means integer type of data, customer ID, I think these are not important. Surname is like object. Why it is object? Because categorical data we have. Why it is? Why? Because we are having a categorical data. Now after that, we have geography, gender, these are also again a categorical data. And tenure, we have balances in the float. We have estimated salary also in this data, and exited again like 0 and 1. Now after that, if you want to see the entire information related with your data, so how you can check? So just simply write like df.info method. df.info method, with the help of this, you will get the information related with your data set. So in the data set, here you can see which class it is first. So it is a class of pandas.core.frame data frame, which contains 10,000 entries. It is started from 0 to 49. Data columns, total number of columns has 14 columns. How many? Like this is the thing, like 0, 1, 2, 3. This is the data pre-processing part which we are doing right now. Firstly, we are understanding our data. We need to understand the data. We need to clean the data, and then after it will be ready for predicting the outcome. So here we have like df.info, which contains 14 columns data, all the data type information. Is there any null value present in the data set? So total we have 10,000 data. So here you can see 10,000 non-null value, which means in our data set there is not any null value. You will also see the matrix here, like total number of data types for float value is 2. Integer we have like 9 values, and object we have 3 different values. And what is the memory usage for this particular data? That is 1.1 MB. If you want to know about, is there any null value present in your data set, and how many null values are there? So what you need to do is just simply write like df dot is null function dot sum function. So if you run this, you will get information related with your data set. Is there any null value present in your data or not? So if I run this cell, I'm getting here 0 in all the columns. Why? because we already seen when I'm written df.info, here we are getting an information related with this data set which contains non-null values. So currently we don't have any null value presented in our data set. So we don't need to be clean the data. We don't need to be perform like we are not need to be handling the missing values right now. Now what we need to do is we need to be import the library for data visualization. So we are going to be import the library for data visualization. So I'm just importing. Sorry for that. Yeah, here I am importing. So I'm just importing essential library for data visualization. So I'm just write like matplotlib dot pyplot as plt. This is how like I import the library. And after that, I also need to be import cvon library. So I'm just write like cvon as sns. Then after I'm just running this cell to import both the important libraries. Then after what I want to create a count plot. If we have null values, in that case, either we can drop those values with the help of drop NA function. Otherwise, we have a fill NA also, where we can perform different operations such as mean, median, and mode. Mean we will be calculated, like what are the like mid value of that, and we need to be calculate the mean. Median, which means the average of the data, and mode means number of occurrence of particular data. Suppose one is coming multiple times. If there is any null value present in that data set, so in that case, it will be filled with that particular value. So fill NA function be used to fill those values. If suppose there are number of values that needs to be dropped, so we have a drop NA function also. So right now with our data set, we don't have. So I think it's clear, Beena ma'am. So now we are writing plt dot figure. So I'm just defining the figure size. So figure size, you can give any figure size. Like I'm just giving like 10 cross 10, which means height and width. We are going to be use count plot now. We are going to be use count plot. In x axis, what I want to show the exited. Why? Because our target variable is what? We need to be checked whether person will exit from the bank or not, whether this particular customer will exit from the bank or not. So exited is our targeted variable. So I just want to check how many 1 and how many 0 values are there. So I'm just writing like x is equals to exited. After that, which data we have. So we have a data frame, we stored it into data frame df. After that, we have to create an x label. So I'm just writing like plt dot x label. In that, under that, 0 is basically representing customers is still or customer is stay with bank, and one basically represents just a minute here, 0 colon basically 0 represents customer stays with the bank, 1 represent customers exited the bank. After that, we have a count for that. So plt dot y label. In y label, I'm just giving the count. I'm just giving the count here. Then after, we are going to be give the title. So I'm giving the title plt dot title. Under that, I'm just writing here bank customers churn visualization. And then after, I'm running it. What is PT? Okay, it's PLT, sorry. So here you can see the size of a graph is very huge. So I'm just decrease it to 5,5. So I hope it's visible now. So we have this data which contains 0, which means customers stays with the bank. In this data set, we have around like 8,000, and customer exited from the bank, that represents with 1, which means that they will exit from the bank. This is the count. Total count is 10,000 data, 8,000, nearly 8,000 for staying with the bank, and 2,000 exited from the bank. So I hope you all clear with this graph now. I hope you all the participants clear with this graph. Okay, fine. Now, if you want to check the unique values, if you want to check unique values, so how you can check? Yeah, sure. This is count plot exited. If you want to check unique values, suppose I want to check unique value for geography. I want to check unique values for gender. So how we can check? Or if you want to check the number of values for particular data, suppose. So how we can check? So I will show you like df of exited. If you want to check unique values, so just simply write like unique function here. It's not comma, it's dot. Unique function, yeah, 1 and 0. In the same case, like if you want to see for geography, suppose we have geography column also. If I perform this, I will get like France, Spain, Germany. In the same way, if I want to check for gender, suppose these are the object column, geography and like gender. But I also want to know how many number of values that are associated with France, Spain, Germany, and in case of gender, female and male. So how can I check it? So in that case, I have to write geography. No need for unique. Right now we need to be check the value count. So value underscore count function we need to be value underscore counts. So here you can see with the help of this function, we are getting an output as France associated with 5,000 value in the entire data set. Germany, which is around like 2,509, and Spain we have like 2,477. So in the same way, if you want to check with the male and female in the data set, just need to be change the gender here. So total number of values that is associated to male according to this data set is like 5,457 customers are male and 4,543 customers are female. So this is how like you can also count the values that is associated for particular categorical data. Now we need to be convert the categorical features into numerical features. But before that, we have to drop some column. So I'm just showing once again df.head function. So please tell me which column is not important to predict the outcome. Which column is not important? So I will drop those columns. Row number, customer ID, surname, credit score, geography. Surname is not important. Okay. And others? Customer ID. Any other? According to this data, we have to remove or we have to drop row number, because row number again nothing but a number, serial number. Customer ID is also not important. Surname is also not important. Credit score is important. Location is very important. Gender is important. Age is important. What is the tenure with that bank? Balance is important. How many number of products? Number of product means services they are. Saving bank account, current bank account, or FD they have, any other policy they have with that bank. So these are number of products. It's also important. If they have an FD, why they will exit from the bank? It's also an important thing. They have a credit card or not for that particular bank. Is he or she an active member for that bank? What is the salary of a person? Based on that criteria, it will decide whether he will stay with the bank, he or she will stay with the bank or not. So we have to remove these unnecessary, these three columns, which is not required for predicting the outcome. So what I need to do is, I just need to be write like df dot drop function. Under that, I need to be give the name as row number. We have customer ID. We have another column that is called surname. So these three columns are not important. So if I run this, df dot drop, yeah, we also need to be defined from where you need to, why we are getting this error, not found the axis, which means that we are removing these columns. So you need to be defined axis. Axis is equals to 1 represent column. Axis is equals to 0 represents rows. So from column, we need to be remove row number, customer ID, and surname. So I need to be passed one more parameter, that is called axis is equals to 1, and that in place is equals to true. From column, I want to remove these three columns. If I run this, and now I want to check the data set, df.head function. So here you can see right now our shape is different. Now it's removed from data, row number is removed, customer ID is removed, and name. These are the data pre-processing steps. Participants, these are the steps which we are following right now, which we are doing right now. These are the data pre-processing step. After this, we need to perform a feature engineering here, where we need to be convert categorical feature. What are categorical features? Geography is a categorical feature. Gender is a categorical feature. How you will know? If you want to know, so you just need to be write like describe function to check the statistical information related with the data. So in which place, like we are going in place is equals to true is a parameter, like in axis is equals to 1, which means in column I want to drop this data, and which place in column basically axis is equals to 1. So that is why we need to be write as true here. That is one parameter, Mr. Amir sir. So here you can see the statistical information related with our data, like credit score, age, tenure, balance, number of products, has a credit card or not, is an active member or not, estimated salary, and exited. This is the table which we already discussed, like mean, standard deviation, minimum value, 25% of data, 50% of data, 75% of data, and the maximum data. Now, we have two columns, geography and gender. What we need to do in this case? We need to perform a feature engineering and convert those categorical features into numerical features. So what are the different methods we have? Yeah, I will show the step for dropping. df.drop function passed a list of the columns. Axis is equals to 1 representing column. From column, I want to drop it. So that is why I'm just passing the parameter as in place is equals to true. Encoding, yes, definitely encoding. After encoding, we have to perform one hot encoding, and then it will convert it into the column transform we will get. I hope you heard about get dummies function in pandas. I hope you heard about get dummies function. Axis is equals to 0 in that place. For row, axis is equals to 0. I hope you heard about like dummies, basically get dummies. What does it mean? So pandas get dummies will turn your categorical variable into many dummy indicators variable, which means that from a series of labels, suppose from a series of data we have France, Spain, and which unique value Germany. These three are the value. If I perform in this particular column, pandas dot get underscore dummies, it will create many dummy indicator variables. It will convert France, Spain, Germany as and list of indicators such as 0, 1, 0. 1 is representing for Spain and 0, 0 for France. Wherever the France data will come, yeah, label encoder we can also perform. Label encoder is basically used to convert a categorical data into numerical data. But if we have, after that, we also need to be perform one hot encoding. If we are dealing with the data frame, so we can go with the pandas get dummies. It will reduce the task basically. It will help us to reduce that particular task. So that is why I will prefer to go with the get dummies. Yeah, obviously, like in general, we will go with label encoder. Label encoder, we have to load that and we need to fit and transform the data for that particular columns basically. And that will convert it into the encoded format where encode is start from 0 up to n. So 0 will be initialized, alphabetically it will follows. So in that case, basically 0 for France, suppose, then 1 for Germany, then 2 for Spain. If we apply label encoding in this particular column. So right now we are using get dummies function with the help of that converted into columns. So now what we are going to do is we have to perform this operation. So converting geography and gender column. So what I need to do here is I have to mention geography. Geography is equals to pd dot get underscore dummies function. Under that data frame, wherever geography column is present, geography column. What I want to perform this, and I want to write drop underscore first as a parameter, like first column, first data you want to remove or not. First data means if your drop underscore first is equals to true, in that case France will not be encoded, that will be removed from the data. So what you need to do here is you have to give this parameter as false in this case. Thank you. Yeah, it's variable as geography. So pd dot get underscore dummies. In this particular data, geography, I want to convert into a list of indicators. And first is equals to false. Why? Because I don't want to remove any data from this particular category, this particular column. I want to add all the data, France, Spain, Germany. So in the same way, we have to perform for gender. So just copy and paste it, change the column as gender here. Here also you need to be changed as gender. And now you can run this. Once you run, it is now converted geography and gender into that particular column. So suppose if I will show you df.head function now, here you can see it's remains same. Why? Because we have to drop these columns and we have to concatenate these two variables into this data frame. So what I need to do in this step, appending the columns to the original data frame. So I have to write like df is equals to, we have another function in pandas called concat, that is for concatenation in between two different columns. So df dot, pd dot concat. In that I'm just writing like df here for data frame. I want to add these two columns. Geography, so I need to be passed geography, comma, gender. So I have to pass gender also. After that, where you want to add this? I want to add this as a column. So axis is equals to 1 in that case. And then after I have to run this. Once I run this, if I will show you again df.head, you will be able to see geography and gender is already there, but few more columns will be added. So here you can see I don't need to perform label encoding. and one hot encoding. It reduced that task with the help of get dummies. Automatically it's converted. So France is separate column, Germany has separate column, Spain has separate column, female has separate column, and male has separate column. So if the particular value is associated with that particular column, that will be marked as 1. Otherwise, it will be marked as 0. So now we have use for geography and gender. Participants, we don't need to be no use geography and gender because we already create a separate column for that. So what we need to do in this case, we have to drop those columns. So how we can drop? Same thing. In that way, I'm just copying df.drop. You have to drop this geography. So I'm just copy it, paste it here. Gender also I need to be paste it. Yes. So now here df.drop, we have like geography, gender, surname we already removed. Axis is equals to 1, in place is equals to 2. If I run this, now again I want to check. Again I want to check the top 5 rows of data. If I run this, so here you can see gender and geography is now also removed from the data set. So we are having credit score, age, tenure, balance, number of products, has a credit card, is active member or not, estimate salary, exited from the bank or not. And after that, we have 3 different columns for geography, that is France, Germany, Spain, female and male. Now, if you want to check the shape of your data, it's now changed. It is now 14 columns we have. So 13 column is important to predict the outcome, like whether a particular person or a customer will stay with the bank or not. So now data pre-processing, we perform these operations. We have to split the data set into independent features, that is called X, and dependent feature, that is called Y. So now what I need to do is, we have to split the data set further into training and testing set. The correct way, basically, like we go with label encoder also. Is there not any specific way, like we can go with get dummies only, or we can only go with label encoder? We can use it. Now we are going to be apply, like first of all, we are going to be split the data set into independent and dependent features. Then after, we will split the data set into training and testing. After that, we are going to be apply feature scaling to the training and test set of independent features. So here, if I scroll up, here you can see, scroll up pd.concat. Yeah, 30 number cell pd.concat, data frame name, and the columns axis is equals to 1. After that, yes, we will normalize the data. We will apply feature scaling in that case. Now, I'm just writing X is equals to df dot drop. Which column I need to drop? Exited, because this is our targeted column. From where you want to drop? Axis is equals to 1. If I run this and I want to see the X data, So this is my X data right now. I want to check X dot head function. So here you can see these are the independent feature. Independent feature means these are the predictors. Based on these parameters, it will predict whether customer will stay with the bank or not. So independent features we created. I'm also giving the name as independent features. Now after that, y, that is called dependent or target variable, target feature, target variable. I'm just writing. Target variable is y is equals to df of exited will be our targeted column. So I just need to be right. Y dot head. I will show you top 5 rows of data. So here you can see these are the data we have. The y like 101000. These data basically. This data. Now what I need to do is after this, we have to split the data set into training and testing. So how we split the data? So from sklearn dot preprocessing. Sorry, we are doing train test split. So sklearn dot model underscore selection. Model underscore selection. We are going to be import train test and split. Train underscore test underscore split. After that, we have like x underscore train data, x underscore test data, y underscore train data, and y underscore test data. Why we are dividing the data and splitting the data into training and testing? Because it's important, like how in which range you want to train your data and in which range the particular data set will be going for testing. So we will take the ratio as like 80-20. So I'm just writing is equals to train test split train underscore test underscore split. It's basically split. In that, I'm just passing x and y. X is my independent feature, y is my dependent feature. Then after I have to define the size. So test underscore size is equals to 0.2. That is 20% of data I have given for testing and 80% of data for training. And random state, I'm just assigning as 0. Or you can give any other number as well. So randomly it will take the testing and training data. So default I'm just giving as 0. You can also change the parameter for that. So if I run this, after that, I already show you the data frame shape, that is 10,000 rows of data and 14 columns we have. After performing independent feature and target feature and performing train test split, what we have to do is here you have to write, I want to check, like I'm printing the x underscore train. I'm printing x underscore train dot save. In the same way, I will show you for x underscore test y also. So this is for x underscore test dot save. This is for y, and here y underscore test. So here you can see the shape of the data. So 8,000. So 10,000 total we have data, that is divided into 80 and 20 ratio. 80 is for training data and 20 is for testing data. So 8,000 data for training with 13 column and 2,000 data for testing with 13 column. 8,000 and 2,000 for y, because this is our targeted variable. So this is like 8,000 and 2,000 in that case. This will be our targeted column. So this is how like we train and test the data. Now we need to be perform a feature scaling. So why I'm getting gender not present in this code? If you scroll up, you must need to be checked like this. Please check Ridhima ma'am. Spelling, yeah. Please check with the spelling. Is it correct or not? So now we are going to be apply feature scaling here. So how basically we are going to be used, and what is the purpose for that? So two most popular techniques for scaling numeric data to modeling that are normalization or standardization. Normalization scales each input variable separately to the range of 0 to 1, which is the range for floating point values, where we have the most precision. Standardization scales each input variable separately by subtracting the mean and dividing by the standard deviation value to shift the distribution to have a mean of 0 and a standard deviation of 1. If you drop those column and you want again, you have to load the data set once again in that case. Data scaling is recommended for pre-processing step when working with the classification problem majorly. And in that, we are going to be apply the standard scaler here. So we have two options, normalization or standardization. So we are going to be follow the standardization. A standardization data set involves rescaling the distribution of values so that the mean of the observed value is 0 and the standard deviation is 1 in that case. So like normalization, standardization is also be useful and required in some data pre-processing step when your data has input values with different scales. So we are going to be performing a standard scale here with the help of standardization library. So we can demonstrate the usage of the classes by converting two variables to the range of 0 to 1. So we will use the default configuration in that case. So how we can do that? So in this case, we are going to be apply the feature scaling. So I have to write from sklearn dot pre-processing library. We are going to be import standard scaler. Can we save same file for different column? Yes, you can save if you want to use that's data frame which contains such as like independent feature. You want to save it, so you can use like read to see like 2CSV, the data like name of that file 2CSV, and pass that CSV file name, and you can save it. Yes, we can do with the like images as well. Tomorrow we have a session for convolution neural network where we can discuss about this thing, image classification as well. Yes, Bharti ma'am. So we drop geography gender here. Then we check with the top 5 rows of data. Then we check the shape of it, create independent and dependent variable. After that, we split the data into training and testing, where we checked it. After that, we are performing the standard scaler here. So I'm just creating SC is equals to standard scaler. So I'm initializing here the object for standard scaler. So I'm just writing SC as an object for that. So a standard scaler object we created here. So in xtrain data, I want to perform. So what I need to do is I need to be write like SC is equals to SC dot fit underscore transform the data. And in that, we need to be pass the extrained data here. Before that, I will show you some extrained data, so you will get information related with that data set. So extrained data is this. Right now we have, this is the extrained data. Now if we perform this operation, after this operation, the data will change into the standard scalar format. C dot, we are going to be transform the X-test data itself. So if I run this, and now I want to check the extrained data. So here you can see the difference. It is now in this particular range. Negative to the positive. Negative to positive range. So hope you all are in the same step. So standard scalar basically like negative to the positive range basically we have. In which step you all are basically? I think we are running out of time, and after this step, we have to build a neural network. Yeah, X-test should be like fit underscore transform. Current step, yes. Done. After this, we are moving on to the next step, where we are going to build a artificial neural network. So I'm just giving the heading as ANN. So now we are going to be applying ANN on this data. So here, ANN are one of the main tools that is used in ML itself. So the neural part of the name that is suggested right now. So in that we have like input layer, hidden layer, multiple hidden layers, output layer, and activation function. Activation function before output layer, and then after output layer we will get the output. Now what we are going to do is, in activation function basically we have a summation along with their bias, along with the bias tree. Yes, 0 and 1. Now we are writing here, import the Keras libraries. Please import Keras, because we are using the deep learning libraries. So we have to write import Keras. So I'm importing Keras library here, importing Keras libraries and the packages. In that, we need to create a model. So we need to be initialize the model with the help of sequential. So how we can do that? We just need to be write like from Keras dot models, we are going to be import sequential. After that, we also need to be import layers. Dense layer is nothing but we are going to be use hidden layer here. So hidden layer is nothing but a dense layer. So Keras dot layers, I'm just writing, where you have to import dense layer. It's dense, and D is capital in that case, and for sequential S is capital here. So please import the Keras library, because we are going to be use a deep learning based artificial neural network. In machine learning, we use sklearn. In deep learning, we use like TensorFlow, Keras, Caffe. There are different frameworks for that. After that, we need to be initialize the artificial neural network model. So we have to write a model is equals to, I am initialized with sequential function, sequential object. So here we create or initialize a model with sequential. After initializing, we have to add input layer and the hidden layer also. So how we can do that? We create the name as model dot add function we have. In that, we have to write dense. Under that dense layer, I have to initialize the neurons. So I am taking any number of neurons here, 6 neuron, 5 neuron, 10 neuron, 20 neurons. So right now in the first layer, I am just writing units is equals to 6 here, comma, you have to write activation function, which we already discussed. So activation function, we are taking care as Relu here. Rectified, I told you it is widely used activation function in neural network. And we also need to be initialize input dimension. How many inputs are there? So can anyone please tell me how many number of inputs we have? Can anyone please tell me how many number of inputs we have? 13, correct? So we need to be defined 13 here. So this is, we are adding the first dense layer and the input layer. So input basically we have 13 and also we are having working as a dense layer. Now we need to be add, I'm just running this. I'm running this. If you are working in the local system, Devasi sir, you have to install the TensorFlow Keras. If you install TensorFlow, it will work. Keras worked in backend for the latest version of TensorFlow. So you don't need to install Keras in that case. If you're working in local system, if you are working in Watson Studio, you don't need to be install it. Working on IBM Cloud, just simply write import Keras. It will work. How many of you are able to import the Keras libraries? Yes, please. Now we are going to be add the second layer. So how we are doing this? I'm just adding dense layer activation function. Now we don't need to be initialized because this is the hidden layer. This is the second hidden layer basically we are having. So I'm just running this also. After that, we need to add the output layer. So in that we have two hidden layers and 13 with 13 inputs basically. Now, what we need to do is, yeah, multi-layer perceptron is there in sklearn, but we are going to be work with ANN. So in that case, we are going to be used like Keras and TensorFlow. 13 input dimension is 13. Why 13? Because we have these data, na? 13 data, credit, age, tenure, balance, and all. So here you can see in the shape we have 13. So that is why I'm passing here. Now after, I'm just adding model dot model dot, we are adding the output layer right now. Model dot add. In that, I'm just writing like one more dense layer I need to be add. Right now, units will be one. Why one? Because we have two possibilities: exit from the bank or not. So here we have to write dense layer here and units is equals to 1. And which activation function will apply here? Which activation function we will apply? You can add multiple hidden layers. I am adding only two hidden layers right now. You can add any number of hidden layers. Sigmoid. Sigmoid. Softmax is for multi-class classification. After that, we need to be compiled. So this is how like I'm adding the output layer. This is the output layer. These two are the dense layer. After that, we have to compile the ANN. Units are nothing but the neurons. This unit representing one outcome at one will be the outcome in that case. Either it is exit from the bank or not. You can also change these units. You can give any random numbers itself. These are the neurons basically. Now after that, we need to be write model dot compile function where we are compiling the artificial neural network, where we are using optimizer and that optimizer we are using as Adam. I will explain in brief about Adam also. And we are calculating the loss. So which type of loss we need to be calculate here? We need to be calculate binary cross entropy, because this is a problem of binary data. So binary cross entropy, and what we want to calculate? We want to calculate the accuracy. So matrix is equals to accuracy. So we have to write accuracy here. It's accuracy. So this is how like we are compiling our model. Why we are using optimizer as an Adam? So Adam is an optimizer to reach the local minimum, which means that Adam can be a combination of RMS prop and stochastic gradient descent with momentum. Adam is an adaptive learning rate method, which means it computes individual learning rates for different parameters. Its name is derived from adaptive movement estimation, and the reason it is called as Adam optimizer, that is used for estimation of first and second movement of the gradient to adapt the learning rate for each bits of the neural network. Again, I will repeat once again why we use optimizer as an Adam, because we need to reduce the error. We discussed about that. We calculate the cost function. Our main goal is to reach the local minimum, which means we have to reach the local minimum errors. That is our main purpose. So here we are using optimizer as an Adam, because Adam is an adaptive learning rate method, which means it is used for computing individual learning rates for different parameters. As its name already suggested, that adaptive movement estimation. And the reason that is called Adam used for estimation of first and second movement of gradient to adapt the learning rate for each weight in the neural network. So understand what is movement. We are talking about adaptive movement estimation. What is movement? So movement of a random variable is defined as the expected value of that particular variable to the power of n. So we are running out of time, otherwise we will go in depth about Adam as well. So the first movement is the mean, and the second movement is uncentered variance in that case. So Adam as an optimizer we are using, loss we are calculating as binary cross entropy, and matrix as an accuracy. We have to calculate the accuracy. Now after that, this is the final step where we are fitting the neural network to the training set. So I am writing here as model underscore train, where we are training the model, is equals to model dot fit the data. Which data we are fitting? X train data, Y train data, and we have to define the batch size. In one batch, how much data will goes under. So if I'm just taking the batch underscore size as 10 here, and we also need to write the validation split. So I'm just taking validation is split as suppose 70 and number of epochs as 25. So how we can do that? We just need to be write like validation underscore is split, that is equals to, I'm just taking as 0.30, which means 30%, and epochs, that is equals to 25. So what is the length? Based on batch size, it will decide how many iteration will perform in that particular data. So suppose if there are 25 epochs, for running the 25 epochs, how many batch will be there? So suppose batch size will be there as 10. For training, like how many iteration will perform in that case? So if I run this, you will be able to understand. So 560 data it is taking. Why? We are having how much data in Xtrain? We are having how much data in Xtrain? 8,000. What is the validation split? 30% for validation split, 70% for training split. So 8,000 multiplied with 70%, how much data it is? 5,600. What is the batch size I am taking here? 10. So with the help of batch size and the data which we have, we need to be divide. So we will get that number of iteration to perform one epoch. So 5,600, if you divide by this batch size is 10, you will get 560 iteration to perform one epoch. So in one epoch, it's train the data with 560 iteration perform, and we are calculating, it's calculate the loss as 0.52, accuracy as 77%, validation loss, which means testing loss, it's calculated as 0.45, and testing accuracy is 79%. In the same way, we are having 25 epochs. We are having 25 epochs. So here you can see in the final epoch, we are getting the final accuracy of the model. It reduces the loss. Here you can see in the 25th epoch, I am getting 0.33 as a loss. And in my first epoch, I am having 0.52. Our main goal is to reduce or reach the minimum error. So this is how we are going to be calculate and train our model. So our training model, we are getting an accuracy as 86% and test accuracy as 84%. Now what we need to do is we need to be classify our data. Which data we need to be classified? X test data we are trying to classify. So I am going to be predict the test set result. So how I can do that? Y underscore pred, that is equals to, we have model. So I am predicting model dot predict function. Under that, I need to be passed X test data. So if I'm passing X test data, I want to check validation split is basically how much data we are going to give for training while fitting the model. So total X train data 8,000, Y train data is also 8,000. If I'm just writing validation split as 0.30, which means 50% for validation, for that training data also again we split it. Total 8,000 data again split it into 70-30 ratio. So 5,600 for training, 2,400 for testing, in that way. So this is how we predict the data. Now I want to check the values. So Y-pred values I'm getting in this particular range, like 0.306, because we standardize our data. So now we are going to be checked if our Y-pred value is greater than 0.5, then based on that, we will check whether a person or a customer having high chance of exit or not. So if more than 0.5, which means there are high chances for exit from the bank. And if it is less than, it means we are having in this data, based on the data, the customer will not exit from the bank. So I will show you. So here Y underscore pred is equals to, in bracket I am just passing Y underscore pred. If it is greater than 0.5, then what happened? I want to check the value. So according to this data, because there is a huge amount of data we have, we are not able to see here. So right now we are getting false for all the values. but we also have true values here. Sorry for the inconvenience. We are running out of time right now. So please give me 10 to 15 minutes more to complete the task. Then after I will take all the queries. So please be patient for 15 minutes more. Then after I will take all the queries. Now what we are going to do here is we need to predict the outcomes. Our main goal is to predict the outcomes. How we can predict? So I'm just going to create a function, which is a predict function. In that predict function, we have some value. Now, I am having a value that is equals to, we are converting the list of values into the NumPy array. We are converting the values into list of values into NumPy array. I will explain this function once again once we are getting list of values. Okay. So value is equals to, we are converting into NumPy array. Which value? Whatever the value which we receive from this function, this value. Okay. After that, we have to reshape because sample value contains only one record. So we need to reshape those data. So how we can do that? So value is equals to, value dot, I'm reshaping it. It's reshape basically. 1 minus 1 comma minus 1. So I'm reshape the data right now. After that, we need to be transformed. Feature scaling we stored into that variable. A standard scaler stored it into SC variable, correct? So what I need to do here is I'm writing value is equals to SC dot. I'm transforming which data? The value data. After that, we are written what we are written? We are written this model dot predict. So based on that, it will give us the outcome, like whether he will be stay with the bank or not. So model dot predict which value is it goes into this parameter. This value will go into this parameter. So this value will go into this particular parameter. So now that predict we are getting, and we are creating this function. Now after, we have to predict the outcomes. So participants, I just want to know which values we need to be predict. Can anyone please tell me? We have lots of values: credit score, age, tenure, balance, number of products, and all. These are the values which we are going to be predict, correct? These values, with the help of these values, we are going to be predict the exited one, correct? So I'm just defining this. Okay. Now after, I'm giving sample value. So value is equals to this value. I told you the value will goes on to this function. Based on that, it converted into, we will call this function, then only this function will return the predicted outcome. So I will tell you why I'm telling. So first of all, what we need to do here, credit score. So I'm giving credit score as 738, age of a person as 62. Then we have credit score, age of a person, tenure as 10, balance. So suppose I am giving the balance as 83,000, 8 rupees and 31 paisa. It's 83,000. Number of products. How many number of products they have? One product. They have a credit card or not? Yes, they have a credit card. Is he or she an active member? Yes, he or she an active member. Now after that, we have estimated salary. So what is that estimated salary? We have an estimated salary as like 42,766 point something like 02. After that, we have like France, which country they have basically, they are located. France, Germany, Spain, female or male. These are the 5 parameters is now remaining. So suppose he is from Germany and rest of the value is 0. Whether he is a male or female, he or she is a like which gender it is. So the gender is like male in that case. So this data I'm storing into this value variable. After that, I want to call a function if predict. Predict means this function I am calling. In this function, these values will go converted into numpy array. Then it's reshape into that. And after that, we are getting an output. It's converted into transform method, and we will able to get prediction. So if predict of those value, the value which we are having, if predict value is greater than 0.5, then what happened? We are printing the statements high chance of exit, high chance of exit from the bank, else low chance of exit from the bank, else we are printing low chance of exit from the bank. If I run this, so based on this data which we are giving to our model, is predicting that there are low chance of exit from the data, which means that the particular value which is converted into the standard scalar format, which is less than 0.5. That is by low chance of exit. In the same way, we are taking one more example. In the same way, we are taking one more example where we change the parameters now. Now, here we are changing the parameter. Suppose I'm just taking here as 805 the value. The age of a person is like 45 years. Now, after that, we have like 9 as a tenure. The salary of a person. So, salary of a person is basically like we are taking like 1,16,000 and some random number like 585.1 suppose. After that, we have credit card is an active member. After that, number of products, 1 has a credit card, yes. Is active member, no, in that case suppose. And they have a balance, salary here. So it is like 1,89,428.45. Then he is from Germany again. And now we are taking an example for female, and this is 0. And now run it. Here you can see we are having a high, it means this customer having a high chance of exit from the bank. Based on this data, there are less chances from exit from the bank because he's not an active member. Is like credit score is good. He can shift and go for the another bank. She's like a female candidate, a female customers basically. So this is like here you can see who is the loyal customer and who is not the loyal customer of this particular bank. So loyal customer, which means high value, low risk, and those who are not loyal customer, which means high value, high risk, or low value, high risk. So these type of customer will leave the bank, and those who are loyal customer, they have high value but low risk of chances to exit from the bank. So this is the entire pipeline which we create. Firstly, we followed the data pre-processing step, where we import the libraries, load the data set, perform data pre-processing step. And after that, we are performing different operations onto this data set. Then we split the data, perform feature scaling. Then after creating a pipeline for the deep learning based artificial neural network, where we initialize the model, where we create add input layer and that first density. After that, we have another dense layer. Then after we create another output layer, one output layer basically, two dense layer we have, two hidden layers, and one output layer, which is a type of sigmoid. Optimizer we use as an atom. Loss we calculate as binary cross entropy. Matrix we calculated as accuracy. Then we fit the model. I already explained what is the use of X train, Y train, batch size, validation step, and epochs here. Then after, we are using directly model.predict function where I'm just passing X test data and I'm getting these values because it is converted into the standard scalar format. If Y pred value is greater than 0.5, then high chance of exit from the bank. If it is less than that, there are less chances from exit from the bank. So in that way, entire thing basically process. Then we create a function here where we convert it into numpy array, reshape the data, and performing standard scalar again and predict the outcome. So where we check with two different inputs and we are getting an output as for first input, low chance exit from the bank, and another we are having high chance exit from the bank. So I hope all the participants understand. I hope all the participants understand. So we will also share, I think you all understand the entire pipeline and the artificial neural network. Yeah, in recording basically we will also share the feedback form. So please provide your important feedback in that. From day 1 to till now, please provide your important feedback. Please provide your important feedback once in this particular form. If you want to save the trained model in Keras, basically it's very easy. Just need to be import like model.save and give the model name along with .h5 extension. So you will be able to save the model also. So we generally take like 70-30 ratio, 80-20 ratio for training and testing the data. 70-30 and 80-20. Any doubts? Yes, definitely. I will also share this notebook. I will share the notebook in the group, Telegram group. If you join the Telegram group, I will share this notebook also. Please share the feedback form. So please provide your important feedback. Please provide your important feedback. Yeah, ANN. Yes. So ANN is basically inspired by the brain of a human brain structure. That neural network consists of inputs and output layers. Hidden layer consisting of the units that basically transform the input into something that the output layer can use. That is called like activation function. That resultant output of the activation function will be the final output, and that will source into the output layer. The first layer consists of input neurons. Those neurons send the data to the next layer, which in turn send the out neurons to the third layer. And ANN are considered as non-linear statistical data modeling tools, where the complex relationship between inputs and outputs are modeled or patterns are found in this case. Yeah, we can solve lot of problem with ANN. Telecom churn, we can also classifying. Uh, Suppose if you are applying for loan, so loan will be approved in your case or not. So such type of problem you can solve with the neural network. The class classification also you can perform. Like in healthcare also, like drug classification was there, credit score, GDP, these type of uh, hospital readmission, mental health. So you can create with the ANN. You can also classifying the reviews like positive review, negative review. With the help of neural network you can create it. That is again a classification model. I'm again sharing the feedback form. Please provide your important feedback. Yes, I will try to share the notebook immediately. Definitely we will provide the link into. Reshape function is basically here we are having a list that is converted into a numpy array. Okay. Now reshape function is allow us to reshape that particular list into the different format. So reshaping basically means changing the shape of particular list. So reshaping basically allow us to add or remove the dimension of a list. So that is why I used it. Why should we write user defined predict function? User defined predict function. Yeah, predict function because this list we cannot directly pass as a value here to check whether here a customer will exit from the bank or not. So first of all, we need to be convert into numpy array, then reshape the data and convert it into the standard scalar format. And that value goes on to this model.predict. And based on this prediction, it will pass this value here. If it is greater than 0.5, then high chance of exit. If it is less than 0.5, which means low chance of exit. So please explain batch size. Definitely. Batch size here is like 10. How many number of iteration to complete one epoch? Here we are training our data into 25 different epochs. So 25 times our model is training the data. 25 times. In that, validation split is like 30. Here you can see the shape. 8000 is the shape of training data, correct? 8000 is the shape for X train and Y train data. We passed it to fit the model here. Then I'm writing batch size as 10 and validation step as 30. So which means training split is how much? 70%. 8000 data, if you multiplied with 70%, that is equals to 5600. 5600 data, how many iteration it will take to complete one epoch? So I am taking batch size as 10. So total number of training data is 5600. That will be divided by 10, and we are getting is equals to 560. So 560 iteration will perform to complete one epoch, and epoch size is 25, representing 25 times our model is trained, and every epoch we are getting the less or the minimum loss. 0.52 in the first epoch, but when I reach to the 25th epoch, my loss is decreased 0.33. And in first number epoch, my accuracy was like 77%. Now 86% we are getting in the final epoch. So I hope it's clear now. I hope it's clear. I'm again sending the link, sharing the link into the chat. 100% if we achieve, that is a case of overfitting. That is a case of overfitting. So in that case, we need to be performed, like if we are getting such type of data, such type of outcomes, we need to be performed. Firstly, we need to check whether our data is balanced or not. So with the help of like balance technique, we're gonna apply on the data. Then only we can proceed again. Then again we are going to be train our model. Yes, this is not the fine like the static one. You can change it. 25 epochs, 100 epochs, 200 epochs, 500 epochs, 1000 epochs. You can also change the batch size 10, 20, 100, 50, 100, 200, 300 based on the data size basically. It's clear for all. Where are the videos uploaded? Videos are uploaded into the SmartBridge teachable platform from your SmartInternz login, from your SmartInternz educator login. If you log in successfully, you need to click on externship, then go to learning resource, and after that you will have an option to watch all the recordings. So day 3 today we have. So I think like by tomorrow morning, early morning, the video will be uploaded into the portal. So I hope you all understand, dear participants. I hope you all understand, and we share the feedback form. Please provide your important feedback. Anthony sir, if you are not accessing, please share your screenshot once in the Telegram group. We will check. So from in today's session, we understand about like artificial neural network, where we perform data pre-processing and build a neural network here. Go to your educator login into SmartInternz platform. Please click on externship. Then after, click on learning resources, where you have to sign up into the teachable access. Once you sign up and re-log in again into the SmartInternz educator login, go to externship resources, click on learning resources. After that, you will be able to access the recording. So I hope it's clear. If you're still facing any issues related with the IBM account, any other queries related with the platform, any questions related with session also, please post your queries into the Telegram group. And thank you very much. Like again, like all the respected faculties stay till now like 9:30. So and patiently like patients like listening all the sessions from last 3 days. So thank you very much. And if you have any queries, you can like ask. Feedback, yes, for all the 3 days, whatever you learn, whatever you feel about the Build-A-Thon, you can give your feedbacks. I will again share the feedback link. Yeah, for last 3 days in the same in that feedback link, you can give your entire feedback from day 1 to day 3. Thanks to all the faculties who are present right now also. Yeah, definitely we will share the Telegram link. Just a minute. I'm just sharing. Thank you, ma'am. Thank you. So Telegram link also I shared. Yeah, like we will share the feedback link on Telegram group itself. Yeah, Bijya ma'am. Sure, sure. Be from different background. Understand actually, based on the time I have also to cover all the things. We are already run out of time. So thank you very much. Thank you very much. We'll upload into the we'll upload into the Smart Bridge platform, SmartInternz platform. So from where you can access all the videos. So thank you very much. And if you have more queries, you can ask. Otherwise, I'm going to be bind up the session. Thank you very much. If you have any queries, please feel free to ask. Yeah, dataset link we will share Telegram group itself. So I already shared the IPYNB file, notebook file already shared on Telegram group. And today's one also I will be share. Give me a few minutes, I will share into the Telegram group. So thank you very much. Yes, on the last day I will try to give you an overview like how to use the service. So thank you very much. If you have any queries, feel free to ask. Otherwise, we are going to be wind up the session. Thank you very much. We'll connect once again tomorrow at the same time, 6 to 9. Try to close within the time. Thank you so much. Yes.